Excellent. Hey, everybody. Thanks for joining us for this month's Cosmic Conversations. So today we have guest speaker Sarabeth Gordon. She is an education director at the Pensacola Mess Hall, and she'll be talking to us about their NASA Universe of Learning funded program, Mission the Universe. And she'll tell it a little bit more, so I don't have to do too much of an
Right.
introduction there. But I'll hand it off to Sarabeth, and she can get started.
All right. Thank you so much. Let me go ahead and share my screen with you. And I'm going to make it so I don't see everybody. But all right. So I just want to tell you about the mess hall. We are an all hands-on math, engineering, science, and stuff science center or museum, whatever you want to call us. And we're kind of cheesy, if you can't figure out by the mess name that we use. So when we started this years ago, I don't know when we first started with Universe of Learning, that was like your mission. It's the universe. This is what I was telling everybody at work. So that's why when I do this, everything is mission the universe. And this is our middle school curriculum. So our plan and our goals were this: to train teachers so that we could expand the universe of learning. And so they would also be able to use the great resources that are out there to teach people about the universe and how we study the universe. We also wanted to inspire middle school students, which is a notoriously group of students that are not quite so interested, a little too cool for everything. And the way we were going to do this is do a teacher training, followed up by 4 visits to a classroom to last about 1 class period. We were going to do 1 teacher at 1 school so that therefore they would expand it a little more. Everything we do is hands-on. We're an all hands-on science museum. So everything we had to do was hands-on. And I wanted to make this the best curriculum, or I still want to make this the best curriculum that we can put out so that people continue to use this. So I decided on giving the students exit tickets to use for action research. And I'll explain a little bit about action research in just a moment. And it is also really important to us at the mess hall that we incorporate components of creativity so that we mix in literature, we mix in art, and those types of things as well. So there's a lot of that and a lot of movement, a lot of creativity needs movement. So this is one of the things that we decided to do. So let me begin with the teachers and the schools. In late July of last year of 2022, we got 30 middle school and high school math and science teachers. I was really amazed about the math teachers that came. I wasn't expecting math, but they were really interested in seeing how they could incorporate space research and astronomy into their math lessons, which was really nice. What was nice is we were able to pay these teachers for their time to come see us. And what we did with them is we went through all of, like, almost rapid fire, all of the lessons that we were going to do and show them the materials that we were going to use, so that even if we weren't able to go into their classrooms, they would have some idea of what was happening. We also provided them with a background curriculum. It's kind of a draft curriculum, not very smooth, but at least here's what we're going to be doing. Then we identified 4 middle, and we also had a high school that joined us as well. We are in a county called Escambia County. So Pensacola is in Escambia County. We were hoping to reach some of the higher need schools in Escambia County. They are having such a difficult year, they weren't able to invite us into their schools. So most of the programs that we're doing are in a neighboring county called Santa Rosa. This county is rural, where we did the 3 schools that we did this. It's in a small town. That does seem weird that there's 3 schools, that it's a small town, but it's also a Navy town. So there's it's very spread out. So they have a lot of different schools. And then we will also be doing one for the Freedom School. And this is a summer enrichment program for middle and high school students that are most at risk of having basically adverse school effects from the summer slide that happens during the summer. So the grades that we have and we will be reaching are 6th through 12th grades, which is well beyond our original goal of getting just middle school students. Now we're hitting high school students. And I'm not a very tall woman, and I've been around high schoolers that are 6'2". So it's really very interesting. So what do I mean by action research? Action research is paying attention to what's happening. So your own teacher observations, the feedback or instructor observations. I don't really consider myself a teacher, but I guess I am in a way. Instructor observations as well as teacher feedback, but also handing the kids an exit ticket, some kind of formative evaluation, something where you're just trying to figure out what did they get from that, what confused them, and then immediately using that the next time that you're in the classroom or the next time you're doing those lessons to constantly make changes. So this is what the action research was. This small image right here, that's an example of the exit tickets. Like, what would you be doing for a space agency like NASA, Space Force, SpaceX, or Blue Horizons? I got all of those because the kids were like, oh, you have to ask us about all those other things, not just NASA. And I was like, okay, let's do that. And these are considered, you can consider them like 1-minute papers or something like that. And I only asked for kids' initials because I didn't want to bias my own self when looking at all of these. So I have a stack of these here of all the things that some of them I have yet to enter in. So some of the questions that we asked for this action research, what is your interest in astronomy or in space? Or could you see yourself working for a space agency? What are some of the things you learned? What things did you find confusing? And ranking the hands-on lab stations that we brought them. And then finally, at the very end, we asked them, not are you interested in working for a space agency, but what would you be doing for a space agency? And I'll go into that a little bit more in just a moment. So our program consisted of those 4 in-class sessions, and the classes we were hoping going to be about an hour, but in reality, by the time they check in and talk and settle down, you have about 45 minutes. So these sessions were a little shorter than we wanted. So we had to adjust things. And one of the ways that we got into the classroom by saying is we're also going to talk about our solar system. Now, the universe of learning is beyond our solar system, but this gave them basically their place in space. And I found this one very interesting because what we did was a pocket solar system. And you can see this picture right here of the end of the pocket solar system. We actually start with the Kuiper belt and bring it in. And the kids begin to talk about the scale and the distances and the relative distances that they're using. And I do remember the anger, and I'm really using anger, of the models that they had in their classrooms. You may have even seen these models with a big sun in the middle and the little planets out and the little L arms that go around. And this kid says, that whole thing is a lie. And I'm like, well, it was hard for me not to say, yes, that's a lie, because in reality, those are. And I said, but we're not talking about the sizes of the planets here. We're talking about the relative distances between the planets. And this had started out with an example from a NASA ambassador teacher that I found years ago of using a quarter for the size of the Earth, a dime for the size of Mars, and like a little pony bead or a little hair bead that you might use as the size of the moon. And that starts out as an interactive show so that I get these middle schoolers to talk to me and be right and be wrong and laugh at me. I happen to know that a pony bead and a quarter have to be about 1 meter away to be the Earth and the moon. And my leg is 1 meter long. So I don't bring a meter stick anymore. I just stick my leg out for them to figure that out, which makes them laugh, which makes them remember, and starts discussion. So they start seeing me as less of a very staid older individual and more of a kind of strange person that's going to use her leg as a meter stick. This works really well to get conversations started about, wait a minute, Mars is that far? Wait, how are we even going to get to Neptune? So that was always really great to do that. However, with the introductory show and the conversation that started with this model solar system, we didn't have time to properly accomplish our next activity, which was drawing orbits and then drawing a Hohmann transfer, which is how you get from one planet to another or one orbiting object to another. We never had time to accomplish this activity. So it makes me question whether or not we should do that introductory show or just jump into it. And there's a balance when you're working with students. You want to be able to capture their interest, but you also want to be able to get through the activities, because this is a really great math activity where you're making your own compass with string and a pen and a pencil, and then you're doing two foci to make an ellipse. It's really awesome, but we never had a chance to do it. So that becomes kind of annoying. Then when we did this, and this is part of the action research, this is the first exit ticket I gave them. Out of the 221 students surveyed, approximately 20% said, yeah, I'd work for a space agency, which is really, I think that's pretty good. Then I listed what they said they would like to be doing. And someone said, no, it'd just be cool to work for NASA. And I'm like, all right, got that. What upset me the most was the reasons for their no's. They didn't think they were smart enough. They didn't think they were good enough. When they had no patience, they were saying they had no patience for math and science and engineering. But what was interesting is over time, they recognized they did have the patience if they were allowed to dive in and ask these strange questions. The other one, the top one that I put there, they're not interested, obviously. Some people are just not interested in it. But fear was a really big factor. And we'll go back to that in just a moment. Our next day was an all lab day. And we began this with looking at measuring things in light years. What's a light second? What's a light month? What's a light year? And how big is the universe? And how big is our Milky Way galaxy? That's a very short video because we want to give them time to do all of these stations. Some of these stations, gravitational lensing, the first time I interacted with Universe of Learning, one of the subject experts talked about gravitational lensing and explained it using this wine glass as a model of it. And we've been using that for years now and watching middle school and high school kids go, oh, okay, that's really cool. So we did gravitational lensing with them. We chose to do cylindrical mirrors and hinged mirrors because that's one way to collect light. And one of the big things that we like to get with the big ideas and subjects is we have to use light in all of its wavelengths to study the universe, because we're not going to be able to go visit all of these places, at least not with our current technology. And as the teenagers would tell me, not with that attitude. I'm like, okay, not with that technology. So we chose to do cylindrical mirrors, and what happens when there's a distorted mirror, the angle in is the angle out for them to get those math ideas. Hinged mirrors, you'll see that it has a star on it. Hinged mirrors are a really cool activity where you can put an object in front of it, and based on counting the number of images in those two mirrors along with your real image, you can calculate the angle of the mirror. The kids loved it so much that this was ranked as one of the highest stations. This interested them the most, mirrors. The other one that interested the most was polymer lenses. I don't know if you've ever seen Orbeez. They make them in small versions, big versions. We use the bigger versions, and this is one in the bottom of a cup here that you're seeing right over here with polymer lenses, where it actually inverts the images. And it works like a lens. It's really awesome, very cool. We chose the polymer lenses for that cool factor. And then also pinhole viewers. Pinhole viewers is a really great way to also see how images can be inverted with light traveling in a straight line and making people think. Interesting enough, pinhole viewers confuse the kids the most. But polymer lenses and hinged mirrors, based on those exit tickets, were the highest rated stations. Something they learned was that lenses invert light. I think they knew that, but they didn't use it. And also that gravity bends space, and space, that to them was probably the most mind-blowing. Now, day 3, told you how we like to have those creative things. This is beyond visible light. We want them to go beyond that tiny little spectrum of light that we as humans can see. So we begin with this poem by Walt Whitman called The Learned Astronomer, in which the learned astronomer is like, math and science just suck the beauty out of everything, is what he's saying. And the kids are like, yeah, I feel that way. And then we bring them the rebuttal of the author Isaac Asimov, in which he uses really amazing poetic prose to describe a black hole. And we give this to the teachers to give the students beforehand. And they come in and they do have this conversation with us. And that's where, like, well, if you're only looking at what we can see, you miss so much. That's the theme of beyond visible light. Now, a lot of these stations are borrowed from the NISENet, or the Informal Science Network. So filtered light is done by that. What happens when you're only looking at one wavelength of light? We have a bunch of different pictures. We give them space images as well. Ultraviolet light, I'll talk about this in a little bit. This was just using a NISENet activity for them using drawing their own pictures on Sharpie, on Post-it notes with highlighters and exposing it to ultraviolet light. And that wasn't doing so well. Infrared light, which is where we're showing them different sensors of using these. You can see in this picture, we've got the digital way to read the infrared light, and then we've got the liquid crystal temperature sensitive paper for them to use as well. Infrared light, as simple as that station was, really got their interest. Years ago, we developed Recolor the Universe, where we 3D printed different wavelengths of light. It's very tactile, and they do different rubbings and overlay the different wavelengths of light to make their own image and their own colors. And then laptop color or cell phone color, or if you can see this picture right here, this is a large computer screen that we had the kids using these small microscopes to look at the different pixels, so that they can see how you can get the color yellow out of all these different, or the color green out of all these different colors of light coming at your eye. That was also a very popular station. The ultraviolet, I'm going to show you this action research in action here. The ultraviolet light station needed help for two reasons. It was wasteful, used a lot of paper, and the students' reactions were like, yeah, okay. Well, so we knew we had a set of fluorescent rocks, and we brought them in, started facilitating the station a little more, and interest in that station skyrocketed, because these rocks, when they're like ultraviolet sensors, when they're in the presence of ultraviolet light, they change colors. It's beautiful and amazing, but also brings me back to the fact that when there's a person that's colorblind, they don't see that. So we also had other ways for them to vision that. So we still brought in the NISENet activity of a little bit, because they could see the change of brightness. That's always for me a humbling moment when I forget that people have very different abilities than I might have. And ones you can see are easy to deal with, but ones that you can't see kind of bring down your excitement level and go, oh, well, how can we make this better? So the ultraviolet light station has changed so much from the beginning, and we'll have to reflect that and also provide these materials to the teachers when we get at the very end. Our last day, this is the most creative day for me. It's what else is out there. I mean, this is part of what we want to do. Like, where do we come from? Where are we going? What else is out there? And we always start this out with a very big question. Do you think we are the only form of life in the entire universe? And there are some kids who say, yes, we're that special. And most of them say, we're not, but they're afraid of what might be out there. So there's some of that fear that I was talking about in the beginning. So we begin this with a really great TED Talk by Aolma Shields. And I have to say, this is so inspiring to me. I've seen it 10 times or more. No, way more than that. And I still get a little teary-eyed from it, because she's really amazing. She's a classically trained actress, and she models atmospheres of exoplanets. It's just the coolest thing that she does. And the kids are like, what? You mean she does this? We're like, yes. And so let's talk about what those exoplanets are. And we bring out the Pocket TRAPPIST-1 system that we used, we adapted from current resources that are out there for Universe of Learning, to do this with another field trip that we had done a few years ago. And in this, we just give the kids all of the different planets, and we're saying, put them in the order that you think they're in. Now they're labeled TRAPPIST 1, B, C, D, E, F, G, H. And you would think it would seem normal for the kids to put them in alphabetical order, but they don't. Some of them do. Some of them put them, the cards are these really small dots, and they look at the relative changes, the sizes, and say, oh, I'm going to put them in this order because this is the way our solar system is ordered. The bigger planets are on the outside. I mean, let's throw away, poor little dwarf planet Pluto out there in the Kuiper Belt. That's what they did. Or they would group them with habitable and non-habitable all together instead of putting the colder planets out. So we got to talk about how that happened. And I'm like, well, what do you think lives on these? And when the technology was available, we would share some of those exoplanet travel bureau posters on a screen. We also have a set of posters that we bring into the classroom. And then we would bring in the NISAC activity called Imagining Life. And this is looking at extremophiles. And extremophiles are life forms on our Earth that live in the most extreme environments, very hot, very cold, very acidic. And these are just 4 of the examples. And we would share these examples with them. I always ended with the snotites because I think they are the strangest, but yet the coolest thing. That's life. And most of the kids knew about the tardigrade because their cute name, the water bear. And we gave them, we're like, let's do this. And I think what was really interesting for the kids to think about what could life look like? And this is just one representative drawing. Because as we spent more time with the kids, we're like, well, what do they eat? Well, what is the environment like? We made them talk at this or explain a little more of what they're doing. And this is just, a mouth hand tendril thing. It's acidic and carnivorous, and it's a semi-solid slime. I'm not quite sure what he means or she means by that. And the chemosynthesizing worm snail. So they were really listening of all these different types of life forms on Earth and how they could do that. And this gives them that idea of what life might look like. So our action research findings, and I know I told you I was going to talk too long, but you can read these things. But I think the most amazing thing is we decided not to let the students say that they would not work for a space agency, because so many kids think you have to be an astronaut to work for a space agency. And in truth, we probably all know this, but we may not think about it, is that there are all these other layers of assistance and all these other experts and people that drive trucks, or I mean, the spacesuits, somebody has to engineer and sew and think about those things. So these are some of the things that we did. We made them tell us, like, what would you be doing? We also, the last question you may see on this card is, what would you send into space? We talked about the records, the golden records, and what would you update from the 1970s? And then again, if you facilitate a station, you're going to get a lot more interest. So what now? Deliver the program to one more school. This will be during the summer. I want to adjust the curriculum to reflect what the findings for our action research. I'm going to share the final curriculum to the participating teachers and obviously to the universal learning. I want to make more sustainable pinhole viewers so they don't get thrown away and smashed. We'll provide a kit of materials to the teachers who invited us into their classrooms. I'm a scientist at heart as well as an educator. I want to crunch the numbers from all these exit tickets to determine if the program shifted the mindset of some of those students who considered themselves too dumb. They did identify with initials, and I can match those up. And I decided, we call this a midlife crisis or whatever, to go back and get my education degree. I am a biologist. I have a master's degree in molecular biology, and I'm now, hopefully in a couple of years, going to be able to call myself a doctor of education. And I will possibly use this for my dissertation. And maybe I can see if I can get one more year of funding to go to a few more schools. But if you have any questions, you can email me. And then my last slide, I'll just share some of the other imagining lives. I have 221 of these, and these are just representative of a few of them, maybe some of the better ones. So I will stop sharing my screen and take questions. And I talked a lot, so I'm sorry.
No worries, Sarabeth. That was awesome. I just want to say I really appreciate how you, with this age group, you're really helping to facilitate that there's pathways into different space agencies beyond just being an astronaut, and sort of having that self-identity as a scientist or wherever their interests may lie, and how that interest can help them identify to being that endpoint of the space agency without necessarily having the barriers to get there when you say astronaut. Because a lot of people just hear astronaut, they're like, that's unattainable for me. But if you say, we also have writers and designers and educators and people, and I love how you say people that even sew the spacesuit or design the spacesuit, there's so many pathways in, and I think kids at that age really don't know that. I didn't know that, and it's so good to have that reinforcement, especially for this age group who are now just starting to think about what the future might be for them and how they fit in the world. So this is really great.
Good. I'm glad you enjoy that. It actually hurts my heart when a kid says they're too dumb to do something.
Oh,
I mean, it hurts my heart
yeah.
so badly. So
Yeah. And that this is the age group where they really believe that too. And it's so disheartening. And you try to reinforce that self-confidence to get sort of picked up more.
yeah.
Um, are there any questions for Sarah Beth? And feel free, like she said, you can email the Google group as well, and we can push the questions to her as well too.
Oh, yeah. Yeah, you're right, Erica. Yeah, there's a lot of things. We ended up, I think a lot of times I felt like I was so rushed when talking to these. And usually, I mean, I'm the education director. So usually I'm not the one always delivering the programs, but I feel such ownership over this one that I want to be the one doing it. And I really want them to think about, like, one was she goes, I just want to do like nails and hair. And I'm like, oh, okay. Well, how can you make that circle intersect with this circle? Where do those two things intersect? Um, but also, if you notice anything that we were doing and you have a suggestion, I am always open to suggestions and critiques. I mean, that's one thing that I love about working at the mess hall is we're very critical of each other, and not in an angry way, but hey, what if you did this? Like the narrative that we tell when we're talking about beyond visible light. We can't see the visible light. So how are you going to make those stations interesting? And we're like, well, these are sensors. So the rocks are sensors. We use UV beads there as sensors. And we have, non-digital sensors for infrared light and digital sensors for infrared light. And so that's, I mean, if you have another narrative, then give it to me, because it's one of those things that we are always trying to make something that we do a little better, a little more engaging, because the wider the wider array of experiences that we have, the more people are going to say, oh, that was interesting. So
I agree with that. And we are right at time at 2:30. So I don't want to hold anyone up here, but if you do have any questions, feel free, like I said, to email us or email Sarah Beth or the Google group. Happy to push any thoughts or questions her way. And thank you, Sarah Beth, for joining us today for being our speaker this month. I really appreciate it. Loved hearing about what you're doing with the program. And thank you all for joining us today. And this will be up on our YouTube page for further reference as well.
okay,
All right.
thank
Take
you.
care, everybody.
Have a good day.
Thanks.
Bye.
That was great.
Thank you.
Thank you. Excellent. All right.
So I recorded it on my computer so I could upload it.